So this is a new playlist, reasoning. This is important because it is the third faculty of Kant, if you like philosophy. And so we should see how a machine can do reasoning. And there are amazing scholars and in the framework of common sense reasoning, especially Professor Schwartz for common sense reasoning, and of course Professor Choi. And there are many amazing scholars in this area. There are very amazing articles written on common sense reasoning, but we should note that common sense reasoning is just a special case of reasoning. There are many kinds of reasoning. There are four kinds of thinking. The fourth one is critical thinking, which human does, and machine is still in its infancy. We cannot do critical thinking in machine in any lecture, in any article in archive, or any journal in machine learning. You cannot even find that. So you see that we are just in the beginning of artificial intelligence. We don't know anything. And I want to explain in particular this beautiful article, which getting help from neighborhood, local semantic averaging for common sense inference in language models. And so what is the motivation? Knowledge graphs, transformer architecture is good. Those ChatGPT 4, and recently in the past few days we had ChatGPT 5. So they are very good at structural things. They can understand the structure of a word. That's why they make beautiful sentences. Although it doesn't have, sometimes it doesn't have any semantic meanings. So the problem is that how can we add the semantic meaning to that? So we need ConceptNet, we need atomic, these knowledge bases for common sense reasoning to augment it. So how can we combine knowledge base with the transformer architecture? Well, the simplest thing is just see that as just an embedding. You combine the embedding of knowledge base and combine the token embedding. You add them at any stage throughout the first layer, second layer, or even the output. And this is a natural approach. So if we can encode and combine the information in these graphs with that of pre-trained transformer, we could supplement and correct information that may be missing or is wrong from the pre-trained models. This gives us powerful language models that are rich with common sense, that's able to read between the lines and tackle more complicated language tasks. So if you want to have a better ChatGPT, they should use common sense reasoning and these paradigms. They should combine it with knowledge base as much as possible. So there are two questions. Can we harness the power of large knowledge? ConceptNet and Atomic are very sparse in comparison to easy knowledge bases that such as Freebase. So our problem is for example, in knowledge graph completion for ConceptNet, is much more complex than knowledge-net, knowledge-based completion of the other smaller knowledge bases. And also it is possible to combine a relational graph, convolutional network, with transformer-based language to achieve better performance gain in transformer tasks. So the fact is transformers can capture syntactic structures very easily, but not for semantic structures. So ChatGPT suffers from lack of semantic structures. So we can combine the transformers with the knowledge bases. How? We use knowledge base as an appropriate embedding and just augment it with the transformer. So they use, for example, we can use graph neural networks for that, for knowledge graph completion. So after you have done your knowledge base and you have obtained those encoding, you just add here with the original token embedding. So this is a good better representation. A representation that also cares about the semantic world that we human are dealing with. So that's why it produces less hallucination. Otherwise, it's just hallucination. It doesn't have common sense reason. Or you can add it at the later stages, such as layer n. So here the task could be anything, but for simplicity they used just the similarity of the questions. Although it's a very simple task, and they cannot fully capture the potential power of these approaches because the task is relatively easy. We just compare question 1 and question 2, and we have a measure of cosine similarity.